Hi, I'm Jim Grouch, and I'm an engineer specialising in mathematical modelling and simulation of complex processes and systems. And in this series, How Things Work, I'm taking an engineering and simulation analysis approach to how society works. Is it what we want it to be, and how could it be changed? After all, it is our society. And in this video, I want to discuss hidden dependencies and how they affect complex systems such as society. So, what are hidden dependencies? Well, the principle is probably best known as it manifests itself with sometimes spectacular results in programming code. And when programming code is controlling machines with people in them, then the effect is of more interest. And that's something to think about as we move towards driverless cars. So first, a hidden dependency is a connectivity of the cause and effect type that is hard to see and which has a significant impact on the emergent result. Some hidden dependencies may be intentionally included and hidden, and some may be errors, sometimes tragic errors. But really, in computer code, all should be predictable. There are a number of examples that have emerged, particularly in the early flights of the A320. And without being alarmist, and I know that many of these images are very alarmist, the A320 could be considered, I think, to be one of the first or the first fly-by-wire commercial aircraft. In other words, control is in the end taken through the computer according to the code. And in some respects, the code was tested by experiment with paying passengers, in that combinations of circumstances were found in commercial flights that were not found or anticipated through testing, offline testing. So with millions of lines of code of linear thinking applied in a complex combination of situations, it's unsurprising that there were some unintentional emergent results found. And one example of this linear thinking was that the air brakes, which are flaps that come up on top of the wings to spoil the airflow and therefore stop lift being generated by the wings, there was the linear thinking idea that the air brakes should not be applied when the aircraft was flying and can only be applied when the aircraft was on the ground. And so a code was included that the air brakes could not be activated until sensors on the wheels indicated that the wheels were spinning sufficiently fast to indicate that the plane was actually on the ground and the wheels were gripping the runway. And this type of code is familiar to process engineers and control engineers in various fields, and it's an interlock of the type that would be something like, if wheel speed less than X, then allow air brakes not. But one day an A320 was landing in heavy rain, and the wheels and though not flying anymore, the wheels aquaplaned and were not spinning up fast enough to activate the interlock to enable the air brakes to be used. So basically the wheels were spinning, but they were spinning on a layer of water. So the plane was not really flying anymore, and as far as the computer was concerned, not landed either. And so the plane overran the runway. And there are other similar examples with the A320. Another example of hidden interdependency may be when one system uses another supplier's system. So you think you're dealing with the Australian government, but they've redirected you to a service provider or have built a system using other commercial systems. You may find filling in the online census that you're told which browser, for example, you may use. And hidden dependencies may be of the type where you think you're dealing with competing entities, but they share common systems and trade between themselves, or share common lobbyists or market evaluation and comparison tools, etc. You may think you're dealing with a local producer, but you find that it is in fact a front for an international supplier or a repackager. But back to hidden dependencies in code. Code is an automated procedural system. It is like an electric circuit. It is predictable and it is open to being engineered for intent. And for example, VW admits that they had code which had hidden links or was not disclosed to change the parameters of their engine's behaviour based on conditions that may mean they were being tested for emissions compliance. And one of the problems with hidden dependencies is that with increasing dependency, the chances for bad results from hidden dependencies increases exponentially, while the ability to assign blame or get fair result or justice from that complex system decreases exponentially. So the point is, hidden dependencies, whether intentionally hidden or inadvertently coded in programming or in procedures, etc., have a profound effect on the emergent results and in driving human behaviour, on the flow of money in an economy and how society works. And another of my favourite books is called Normal Accidents, written by Charles Perrow, with the subtitle Living with High-Risk Technologies. And this book gives many examples and explains how in many ways many of the accidents that are occurring should be considered normal, as they are unintentional but very predictable results of interconnectivity of complex systems. So in some sense, maybe hidden dependencies is one of the main causes or main contributing causes to the phenomena of future shock. But in any case, hidden dependencies and using them as an excuse for what happens has to be considered in our model of how society works. So thank you for your time. I hope you come back to watch a few more of these videos as I progress towards building a model of how society works, whether it remain a thought model to help you think about what's happening, or hopefully it will continue to the stage of being coded, enabling different inputs and assumptions to be applied to see what the result is.